Hey guys, so in today's video I'm going to be starting off by going over Google Colab. In short, I'm going to do EDA but without actually creating any graphs maybe, and then moving on to creating a pipeline. And I'm going to be doing this because some of the flashcards that we're working with here with Anki, mostly I just want to try to remember what they were, in particular our cheat sheet right here. And likewise, I just kind of wanted to gain a refresh on join, merge, maybe concat, since I haven't actually worked with those in quite some time, and then try to see if I can recall bin. So this video is pretty much all just practice. It's practice for me, and yeah, let's just dive right in. So how do we want to start? So what I've done is I've already kind of logged on to Kaggle, and I've already converted to the proper directory that we need to load our dataset from. So let's go ahead and let's actually treat this maybe like a real notebook. So let's go ahead and we'll have like our EDA section, which stands for Exploratory Data Analysis. Let's go with the metrics. Let's go with the pre-processing, and let's use Scikit-learn to do it. We can also do, maybe I'll do two. Like I'll use, okay, yeah, I'll do two. I have an idea for how I'll do both Pandas and Scikit-learn for pre-processing. What else? Just the model, maybe models. I feel like I'm forgetting something. Let's start importing the stuff. So I'm gonna go ahead and just start with like pandas and all the rest. So import pandas as PD, import numpy as np, import matplotlib.pyplot as plt, import cborn as sns, and then what else do we got? So these will be sklearn metrics. So from sklearn.metrics, import accuracy score, recall, precision. Yeah, I'll leave it F1. And let's go ahead and to make it look clean, we'll do it one more time. So from sklearn.metrics, import F1 score, classification reports, and what else was there? There was I'm trying to think. So I think I'll leave that for now. Or maybe, so we also have, would it be confusion? Is confusion matrix in the metric? And then let's go ahead and import our train test split. So from sklearn model selection, import train test split. Let's go ahead and also import random search CV and grid search CV. And then let's also do one more from sklearn.model selection, import, what was it, ROC curve? No, so that would be the metric then. ROC, AUC, and let's go ahead and create it one more time. So the reason I'm doing this is to make it look like, just make it look cleaner. I feel like I misspelled both of those, so metrics. Import ROC score and ROC curve. And then I believe all of these will require y true / y pred. And I'm just actually making this note for myself, mostly because I'm practicing recall. And again, so the reason I'm creating this video is practice for myself. If you find value in it, then that's awesome. But just know that if I was you, and if you're new to data science, I would just kind of start with Anki, which is a flashcard set, which will help you memorize pretty much all these. So like, how would you import ROC curve? You'd use from sklearn.metrics, import it, and then all the rest. So after that, we have train test split, randomized search CV, grid search CV. What else do we have? We have one more that I want to work with, but it would be cross-val score. And I think that'll be it. Let's move this one split it. You will go here, and then you will go here. And then what else? So then we'll go on to pre-processing. So I don't know if I'll use ColumnTransformer. I should, since I need to recall, like I need practice with that. So let's do ColumnTransformer first. So from sklearn.compose, import ColumnTransformer. And the reason I say this is because I actually want to work with pipeline to adjust and use the pipeline for pretty much everything. So I'll do, yeah. I have kind of a game plan I just kind of came up with. So from sklearn.preprocessing, import OneHotEncoder, and then from sklearn.impute, right? Import SimpleImputer, and then one more. So from sklearn.pipeline, import pipeline, and then what else? ColumnTransformer, OneHotEncoder, SimpleImputer, pipeline. I think that'll be it. And then we'll do our models. So from sklearn dot, what is it? Ensemble, import random forest classifier from sklearn. And so to bring in linear regression, I believe we do this, or logistic regression, whoops. And then from there we could do neighbors as well. So from sklearn dot neighbors, import k nearest neighbors classifier. And then from there we could do from sklearn dot s, is it svm? Import linear svc, yep. And then svc. And I'm curious, I've never actually worked with cat boost, but let's see if we can import it. So from sklearn dot boost, is that it? Nope. How would we do this? Import cat boost from xg boost or something like that. xg boost. Oops. Gradient boost, xg boost. I'm not sure. I've never actually worked with it, but let's see. I just want to see like how you would import it. Okay. Import. Truncated SV. No. Train test split. Import XGBoost as XGB. And then we also have cat boost, and we have regressor, but I don't want that. So let's not worry about that. Let's come back to that. Let's come back to that another time. So let's get rid of it. And from there, since we have everything typed out, let's go ahead and import the data. And what else do we want? I guess I'll just do like some quick EDA. I'll do dummies, copy, join, merge, maybe not concat. And then what else? And then from there, I'll go ahead and just look at the data. And like the goal of this isn't going to be trying to find the best possible accuracy score, or any score for that matter. It's mostly just going to be to mess around, to take in different sets of data and just make sure that the vocabulary behind the code is proper. So that way I'm pretty much retaining the knowledge. Yeah, pretty much just retaining the knowledge. And then, yeah. So if we're going to go ahead and import the data, we'll do data frame equals p.read CSV. And then from there, it will be Titanic training.csv, Titanic train. And then from there, we could do df copy will equal dataframe.copy, because I just want to practice with this. And from there, let's go ahead and do the length of data frame, and then the length of df copy. And then from there, let's go ahead and also check out, let's just leave that alone for now. So let's import everything, and I screwed up with one thing. So from sklearn, is it .impute? Whoops, screwed it up again. Nope. And then the next one is from sklearn dot, what would it be? Dot lin, I forget how to import this. So logistic regression would be from sklearn dot what. So let's go ahead and type that out. Import logistic regression sklearn. And what would that be? What would it be? What would it be? Do we have an image that I could just quickly view? Oof. So, nope. Standard scalar. Da 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 da. So it'd be from linear model. So what did I have then? What did I have? Linear model. Oh, I did line model, linear model then. Cool. So now it works. So now we see the reason I did length though right here is so that way I can ensure that both the rows, both the data sets, they had this like the same amount of columns. Well, the same data in essence. So let's go ahead and check out our data from that is NA, and let's go ahead and just get rid of some of the columns. Actually, what I should do is dropped it, but oh well. So from here, let's just do dataframe.drop, and we're going to just drop a handful of columns. So let's do cabin. Let's go ahead and do boat. Let's go ahead and do, what are the last couple? Body, home destination, home dest, and then is that it? We've got, so we got 4 of them that we're going to drop, and then we'll do axis equals to 1, and then anything else. Let's go ahead and do dataframe.isNA.sum again. I gotta do in place equals true. Do I? I thought that was, yeah, I guess I do. In place equals true. And now we see that they're dropped. And then I can always just create another copy after this. So what I'm gonna go ahead and do is a couple things actually. So let's go ahead and recreate that copy that I have up here. What is that called? It is called just df copy. Okay. Oh, that's right there. df copy equals dataframe.copy again. So we're going to overwrite it. So now if we're going to go ahead and view it, it would be dataframe copy. And if we viewed the columns, we'd see that they have the same columns as was right here because we dropped these ones right here and then made the copy. So from there, let's go ahead and split them. So what I'm going to do with our dataframe will equal SimpleImputer. And what I mean by that is aka pipeline. What we're going to do is I'm going to get rid of that. I'll go ahead and use SimpleImputer to fill missing values as well as converting string values to numeric values. I'm going to do this with sklearn. So actually this might be easier than equals sklearn for preprocessing. And then df copy will be pandas for preprocessing. So then, yeah, let's just go ahead and start with pandas then, and then we'll go ahead and view the other way as well. And during our preprocessing, we'll go ahead and use our model with that. So dataframe.copy. What was I going to do? Let's go ahead and create a second copy. So df.copy, and then to make this look nice, df copy. Let's go ahead and create a second one, df copy 2 maybe. Df copy, sure, why not? And then that'll be our data frame copy.copy. And then we'll also have the other one. So, let's go ahead and do this then. So what I'm going to do is let's go ahead and join some of the data from data frame copy to the other copy. And then from there, what I'll do is I'll take the joined data sets and then fill missing values. And then from there, I'll use dummies to just dummy out the data. And likewise, I'm actually going to go ahead and drop the passenger ID, the name, and the rest after joining the data together. So if we're going to go ahead and look at our data frame, if we're going to go ahead and look at like just the top 5 rows for the first copy, .head, no typos. We pretty much see that the data will go ahead and join on the index itself, mostly because the index is unique, and technically I believe, oh, actually the passenger ID should be unique. So let's go ahead and see if that passenger ID is unique, and let's see like what the character count would be. So we'll go data frame dot passenger ID, and then dot unique, and let's go ahead and see what that would be. So that'd be 850 rows. But I'm curious, are we going to drop any of the data? So that's one way of looking at unique, I believe. And then the other way would be data frame copy dot passenger ID, and then that would be n unique. And from there, what is drop NA? So drop NA is default is equal to true. But do we do this in place? Do we have in place equal to true? Nope. So let's go ahead and view what that would be. So again, so it is 850. So regardless of the values in our passenger ID, they'll all have unique values, mostly, and we know this because there are currently 850 rows in the data set. So 850, 850, and 850. And this one would have dropped any nan or missing values, and likewise it will drop values that have duplicates in them. So if we have 2 people with a passenger ID equal to 1, then the total count for passenger ID 1 would be just 1, even though 2 people have it. So that's what n unique will do. And likewise, so 2 will unique right here as well. Yeah. So let's go ahead and join them together. So if we were to join our data sets together, what we could do is we could do data frame copy.join, and from there I believe it would be data frame copy 2, and then on we'll go ahead and equal our passenger ID, and how do we spell it? Underscore ID. And then from there, how equals left, that's what we would want. Yeah, and I think that'd be, in essence, everything we need. So let's go ahead and see, does this do it in place though? Left and right, A and B, okay, so that makes sense. So let's go ahead and just view the data set to get all together now. And we'll get in there. So the columns overlap but no suffix specified. So what would this mean then? So because our columns overlap but no suffix specified, index blank. So I'm assuming that because we have our column names are all the same, I could easily click on this and search Stack Overflow, but I'm going like, again, this is practice for me. So by kind of reviewing the overlap, so columns overlap, that means that in essence, this copy and then our second copy both have the same passenger ID, and it doesn't want to automatically adjust the name, whereas I believe if we did merge, it would adjust the name. So let's go ahead and first rename the columns themselves, and then I'll re-import the data and join them with merge. So if we want to test the hypothesis, what we could do is we could do data frame copy 2 dot rename, and then from there, what would it be? I believe, at least I hope, it would be this, and then we'd want to enter all of our columns. So let's go ahead and just copy and paste them in. And then, is that right though? So data frame dot copy the column. Okay, so because they're looking like this is actually going to be a dictionary, I thought that we could actually do a list, but I guess I'm mistaken. And likewise, this is also one of the flashcards in my Anki data set that I have over here, but I just haven't worked with it in about 2 or 3 weeks, so it's a little vague to me right now. But what I'm going to do is we'll go ahead and just rename each of these on its own, and then we'll be able to join them. So from there, we should be good to go. So I'll go ahead and call each one like a different name. So name will be, what should name be? Name will be about P for passenger name, and then sex can be gender. And from there we could go ahead and do age would be, I don't know, what would be another thing for age? I guess P age, passenger age. And from there we could go ahead and do siblings. And then parch would be parents. Ticket could be P ticket. And then fare could also be P fare. And then I guess we'll just do this for everything. So P embarked and P survived. And then from there, it'll be access equals column. And let's go ahead and see if this will work. Whatever. So rename, and let's see. We did not get an error. Oh my goodness. Okay, so now all these are done. Let's go ahead and review what the column names would be, just to make sure that they were changed, and they weren't. So which one did we update? So we did the dot rename. Do we need to do in place equals to true? Yeah, so in place is actually equal to false. So let's go ahead and do it one more time. And now we see that they're all updated to like a new name. So let's go ahead and try joining one more time. So if we try to join, so we have dot copy dot join, and then from there it would be data frame copy 2, and then on would equal, actually let's not do on, so let's do how will equal left, and I don't really need to type this out, but I am anyway. So we want to do a left join, and then let's do a left suffix, which will be, the left suffix will be from our data frame copy, so that should still be passenger ID. I spelled that wrong, I feel. Passenger ID. Is it 2 S's or 1? I guess 2. It just looks funky for whatever reason. And then the right suffix. So the right suffix will be our ID, since that's what it was renamed to. And since both of these values will be unique, and in essence they will equal each other. So we'll have a perfect data set and alignment And just know if ever you have an index you want to join on, you could always just do index, and that'll use the index position. So we'll do ID, and let's just see what happens. So it looks like it joined. Now if we scroll to the right, we see that we have ID, class, pname, and all the rest. So that's perfect. Okay, perfect. So now that we've joined the data set together, or now that I have, well, let's go ahead and view what our missing values are, fill them, and then drop the remaining values, and then go ahead and use dummies to pre-process our data. So if we're going to go ahead and work with the data frame, so it'd be data frame copy. Actually, would it be copy, or what would the columns be? Nope. So that would be still there. So it does not do this in place, does it? So what would this be? I guess not. Even though we have the join data set together, so copy equals this, and then from there we could do data frame copy. We'll go ahead and equal view the head, right? View the columns, and now we see we have more. So let's go ahead and view our copies missing values, and then let's go ahead and just fill NA with specific values, and then from there I'm just going to go ahead and use dummies to fill it. So let's go ahead and start with the age column. So we'll do df.copy.fillNA to fill the missing values, and from there we'll go ahead and do the, how do we want to do this? So if we fill with a specific value, it would be data frame copy dot age, and then we could do like the mean of it. And then I believe, what would method be though? So let's go ahead and quickly see what method is. And it looks like, oh, that's just backfill or forward fill or whatever else it might be. So there's like some really cool tricks like working with this, like meaning if you were going to work with, I don't know, if you were like, if you had missing value at the head at the start of the data set, like column or rows 1 through 10, and you have data at the very, very bottom, what you could do is you could just fill like the very bottom, the newer data set. So like as new data comes in from the API, hypothetically speaking, if all these new values have a consistent value that you want filled in, then you can maybe use that as your data, or maybe something's like evolving, or in essence, it allows it to be dynamic is what I'm getting at. So you don't necessarily need the mean, but you could like fill the data based on whatever your requirements are. So that's really useful for creating pipelines, and especially with like, yeah, just pipelines in general. So yeah, let's go ahead and just make the end place, which will be true. And then from there, let's go ahead and move on to the next part. So since we're going to fill the age column, let's fill the other one with, so our fair, oh, that's right. So I screwed this up then. So what we want to do is we actually want to select the column that we want to fill the missing value with. So from there, we'll go ahead and do fair.fillNA, and then data frame. Actually, could I use data frame? I probably could, but let's not. So let's go ahead and do just fair.mean again, or like let's just do median just for fun. And then from there, we could do in place equal to true. And then from there, we'll do a handful more. So what have we got next? We would have embarked. And then from there, we could do value equals s. So we'll want it to be like constant. And then just for the sake of this, we'll go ahead and type in value, and then value again. And then we want it to equal s, and then in place it will equal true. And then that'll be the first part. And then let's actually just copy this. Now let's go ahead and add like page, because I think that's what it was called, right? So it would be ID, we have page, pfair, and then embarked. So p age, p fair, and then p embarked. And from there, like, because these values are the same, I'm just going to leave them as is. And then we still want this to just be S. And then from there, let's go ahead and view our, see if there's like any other missing values that we missed. So we have, perfect, no missing values. And then now the fun part. And this will be the last thing for pandas. So let's go ahead and use dummies. So we'll do pd.getDummies. And then from there, we'll go ahead and dummy the data. So all this does is it's very, very similar to what OneHotEncoding will do when we create the pipeline. So what would that be though? Let's use our data frame copy because that'll be what the data is. So data will equal this. And then do we need anything else? So we have a prefix. So this will go ahead and fill any NaN values. Columns, I guess you could select the specific columns, but I just want it to be across the entire data set. Oh no, maybe I shouldn't. That could be bad, or it could be great, just depending upon how you look at it. The reason I say it could be bad is because it would dummy out the entire, like, all the data. So maybe we don't want that actually, because I don't want to wait here for like a half an hour just waiting for everything to populate. So let me check what the data types are first, and then let's just select the columns that have object, and then we'll just dummy out those. Or maybe not, because I don't want to use ticket. The reason I don't want to use ticket is because, again, if we have each unique passenger has their own ticket to board the Titanic, then that would be 850 rows of data, which will then create 850 columns just for the ticket data set, not including everything else. So it'll be 850 columns times 2. So that's just too much. Let's go ahead and drop those columns then. So data frame copy.drop, and then from there we'll go ahead and we'll do fair, and then also the p fair, and then what else? We have names. Let's get rid of the names too, because we would also assume that each person should have their own name. So let's go ahead and get rid of name, and then anything else. So we have ID, class, name. Gender we'll want to keep because that's only 2 values. Age keep. Ticket we're getting rid of. And then embarked is also 3 values. So we'll keep these ones for now since there's only 2 and 3 values. So access will equal 1, and then do we need to do in-place equal true? Yep. In-place will equal true. And from there, let's do df copy dot columns. Misspelled true. And now this shouldn't be too bad when we're looking at the data. And then for fun, just because I haven't done this in a long time, joy. So it pretty much just gives us like a description of the data itself, the mean, the standard deviation, the count, and so on. It's quite useful when looking for outliers when you want to compare even max or the minimum value. Maybe you would want to check out that specific column. But let's go ahead and do dummies now. So we'll want to do pd.getDummies. From there we'll do data equal to df copy. And then we'll go ahead and let's select the columns that we want to dummy out. So let's go ahead and do embarked. Embarked. Let's do p embarked. And then we'll do sex, and I believe the other one we named it gender, right? So what would it be? We have our sex, we drop name, we drop fair just because. Actually, maybe we could have kept fair. Oh well. Drop name, so the other one would be gender then, yeah. Oh, and then we need to do embarked as well, which I think we have already. So that looks good. And then what else do we need? Do we need to do in place equal to true? That'd be interesting. Maybe we could drop. So next time I could consider using that. Yeah, so let's go ahead and just see what the output would be. Joy. So what do we have? What do we have? Survived. So we see that how survived panned out. So survived is still there, but we have embarked. So this will be our first test. So in essence, what happens is because there's three values, there's C, Q, and S, and they all derive from embarked. And so when embarked was on its own, this column would this row, would read as Q because Q is listed as 1. And then this one will list as S because this is S. S is 1 right now, and these two are 0. So it would have been, imagine that this is just the embarked column before we use this, before we call this line, right? So this one would be Q, S, 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 and then again an S, and then finally the first C. So imagine that these would be like just their own like C, Q, or S as a string value. What happens is when we do dummies, it converts the string to a numeric value. So it'll either be a 0 or a 1, depending upon the value itself. So that's for Q. This is for embarked, right? And then now if we go over to sex, it would be either female or male. And so we'd see either 1 or 0. And then just kind of consider like pd.dummies.getDummies for categorical data when something is apples, bananas, and oranges, or when it's like Toyota, Ram, Honda, when it could be a series of things. So yeah, so that was kind of fun. All right, next I'm going to go ahead and move on to our Scikit-learn portion. So this will be Scikit-learn. And let's also go ahead and use pandas. Text, we'll go ahead and call this pandas. And then Scikit-learn. And since we've already imported everything, I'm not really going to be concerned with that. What we're going to do is we'll just build a pipeline. And then hopefully I remember how to do this. Yeah, so good luck. So how do we want to build the pipeline then? So what we want is we're going to work with our regular data frame, not the copy. So we'll just check out the data frame .dtypes just to see like what we're working with here. And what I'm thinking about doing is I'm going to keep all of these values, including the name and well, maybe we want to get rid of the name. So imagine adding 850 more columns because each person has their own name. I wouldn't really want to go through that, so I'm going to drop the name. Ticket will be dropped as well because you would imagine each person has their own ticket. We don't want that. So yeah, so let's go ahead and just drop those two then. We'll drop the name, and then I believe the ticket. And then I don't think there'd be anything else. So in place would equal true. And then from there, we could go ahead and check out any missing values. And x is equals 1. Perfect. So now we just have age, fair, and then embarked. So let's go ahead and create the pipeline. So pipeline. From here, let's go ahead and call it just pipeline. Will equal pipeline. And then from there, I believe it would be steps. And it'll be a list of tuples, if I'm not mistaken. But first, let's go ahead and actually separate the data. So this is usually where I get quite confused, but like when it's written out, it makes perfect sense. Mostly because I've had quite a bit of practice with it, but not enough to remember it. So let's go ahead and do categories for our categorical columns. And then let's go ahead and do, how about average? Because that's where we're going to fill fair with, and age. That'll just be the average value. And then embarked will be its own value as well. So let's go ahead and do categorical column will equal embarked. And then from there, we'll do the transform for it. Categorical, I guess transform. So that's why I created this. Okay. So I knew I was going to be working with the pipeline. I just wasn't sure where it went and how it would be worked. So let's get rid of view. So we'll have pipeline steps, and then likewise, let's go ahead and let's do the average. So how do we do the average? So let's first get the average columns, I guess, and then that'll be fair as well as age. And from there we'll do average transform will be pipeline, and then it'll be steps. It'll be a tuple as well, or a list of tuples. Now from here it will be imputer, and I'll go ahead and pretty much copy this over as well. Like what gets written here will be almost the same, with one difference. So from there we'll do SimpleImputer, and then from there it'll be strategy. We'll go ahead and equal the mean, since we want the average. And then from there we'll do fill value. We'll go ahead and equal constant, I believe. And then so we'll just have this right there. Now what we're going to do, or what I'm going to do for the sake of just practice, so I'll do imputer again, and then we'll do SimpleImputer. And then from there, the missing value will be a constant value of s. So we can either have it be like a mean, and what you could do is you could even select a specific column. So you could do data frame dot age dot mean. But because I don't want to do that, I want it to be the mean for both the mean value of age and the mean value of the fair itself. And then likewise, I want this to be just a constant value of s. So if there is a missing value for embarked right here, then we want that value to be s for this column, and then mean will be the mean for this, and then the mean for this. So they'll be separate means. So let's go ahead and do the fill value as well. But I just want to double check one thing. So we have constant right here, and that would be filled where? This default would be mean. So maybe I mixed these two up. How do we do it? So we'd have the missing value, the strategy equals mean. So the missing value is s. So maybe that's where I screwed up then. So then the missing value would be mean, and then the strategy would be constant, right? I might be confusing myself. Okay, what would the missing value be? So the missing value is a number, a string, or it's nan by default. So missing value will be imputed. So the string default of mean, the imputation strategy. Okay, so let's flip these around then. So the fill value will be s, and then what would it be? Strategy equals? That's right, so then the strategy will equal constant. So now this makes more sense. So you'll fill it with s, and then we want that to be consistent throughout the entire column. Joy. And And then we'll go ahead and mix these around as well. So let's just flip them. So our fill value will not be constant, but it will be the mean. And then will we need the strategy? I just want to pop up so I can read it one more time. Or not. So what would the, by default it is mean. Replaces the missing values using the mean along each column. Can only be used with numeric data. The median would be the median. Most frequent is another one. And then if constant, then replacing missing value with fill value can be used with string or numeric data. Okay, so I guess then what would be the, okay, so the natural or the default for fill value is none. So what I will do is just get rid of this since we don't really need it. And then this will just be mean. Okay, perfect. Yeah, so now that makes sense. Okay, and then next up we have OneHotEncoder. And I'll just do onehot. And we'll do OneHotEncoder, and then we'll handle the unknown. But what will we handle it with? So we have our parameters, and then you drop the first, but we don't want that. So how would we handle the unknown though? So categories, auto list, categories for the first, and shape the defaults. What else do we have? The array of the first, sparse, D types, handle the unknown. So it could be either error or ignore. And in our case, what we're going to want to do is we're going to want to do ignore, if I'm not mistaken. So if the default is error, whether to raise an error or ignore. And we don't want to raise an error because then it would kill our pipeline. But we for sure want to ensure that our missing values are handled. So in order to do that, that's the reason why we're doing OneHotEncoding right here. So let's go ahead and fill the ignore right there. So yeah, so what will happen is this will be triggered first, the SimpleImputer. It'll then trigger any missing values that have a constant value of s. And then from there, the same thing that we did with panda.getDummies right here, as soon as OneHotEncoder is called, then it'll do this. It'll separate them into their own column. So that's just another way of doing pd.getDummies. So now that these two are done, let's go ahead and move on to our ColumnTransformer. And let's transform the data. Transformer. And how would we do that? I believe we could do just ColumnTransform. We'll go ahead and equal ColumnTransformer. And then from there, I believe it would be transformers and be a list of data. Now here's what I usually screw up. So this was definitely a screw up, but at least I was able to kind of figure out how to work through it. This one is definitely eluding me. At least it was until until right now. So what this will do is this will go ahead and take our categories. So we can just call this, no, let's call it categories. How do I spell that? So I misspelled the other one, categories. I actually feel like I misspelled this too. I can't spell, I'm just going to leave it alone. Let's just call this cat for short. So from here, what would we want to happen first? What I think we'll want to do is we'll want to use the columns first, and then we'd want to use the transformer. At least that's what I hope. Now I have a feeling that I'm wrong, but we'll see. And then from there, what we will do is we'll just do average for av, or like average, yeah, av, yeah, I can't speak. And then we would have the columns, right? So if we use columns right here, and then transformer right here, so what this is doing with ColumnTransformer then, in essence, is it's pretty much taking this input and it's ensuring that it's triggered for the specific column that we're working with, right? So, do we need anything else? Well, if we do, I'm sure an error will pop up. And then from there, we'll go ahead and pre-process it. We'll go ahead and equal the pipeline one more time. And is this one also the steps of the list? And then from there, I believe it would be, what would it be? I think we actually just create our own. So we could just call this pre-process. And it would be, what would it be though? I don't know what the pre-process step would it just be pre-process again? I know I'm blanking because I know what comes next will be the model. And then the model would be whatever we needed our model to be. But we want to make sure that we instantiate it as well right here, right? So what would this be then? Why? I can easily go look because I have the flashcard for it. But I want to try to like at least try to recall what it would be. So for the sake of this, what I'm going to do is I'm going to leave it blank, and what I'll just go ahead and come back to it. So if this is pre-processing it, this is our pipeline, and we're calling pre-process right here, what would go right here? Would it be ColumnTransform? Let's go ahead and test it. I think that it will be that. So we'll want the ColumnTransformer to be right here because it triggers all the rest of this. The ColumnTransformer will go. And then, yeah, the ColumnTransformer will trigger. And then this column will be the first one triggered. And then SimpleImputer will go ahead and trigger. And then OneHotEncoder will trigger. And then I believe, if I'm not mistaken, it'll be fair will trigger. The mean value will be filled. And then age will trigger. And then the mean value will be filled. And then from there, it'll, yeah, so it should call the columns first and then the transform. Column first and then transform. At least I hope. If it does error out, then it likely will be flipped. And then we have pre-process, which triggers this. And we're going to have the ColumnTransformer here. And then the model will go ahead and be random forest classifier. And from there, what would we be? I guess it would be pre-process. So let's rename this then. So let's name this model. And then pre-process is just a step that we could call within the pipeline itself. At least I think. And then let's go ahead and just do split our data. And then we'll go ahead and split again. Split into train, test. And then from there we can do fit and then score and then, yeah, all the rest. So rather than doing random forest classifier, let's just do logistic regression since I always do random forest. Now from here, let's go and split our data. So if we have our data frame, what would it be? I believe we'd have our data itself, right? So X would be data frame.drop survived, since that's the column that we want to predict on, and then axis equal 1. And then Y, we'll go ahead and, do we need to in place though equal to true? No, actually we don't, because this is X. And then Y will equal data frame.survived. And from there, let's also make sure we seed the data. So split and seed. So numpy.random.seed, and the reason we seed is we want to make sure that the output is the same across multiple different notebooks. So my notebook matches up with another person's notebook, and then like the score, right? So when you score the data, you want to make sure that your results match another person's results, even though you're using two different machines. So now that we have our data, let's split it into train and test. So what would that be? So I believe it would be xtrain, ytrain, or xtest, habit saved me right there, and then ytest, test, and then we'll do train test split. From there we'll have x and y, test size, test size, I need the test size. We'll go ahead and equal 0.2. Yeah, I'll leave it at that. And then from there we'll have model dot fit, and then it'll be xtrain, ytrain, train, and then score it. But let's also go ahead and do predict. So we'll have ypred equals model, no, what would it be? I believe it would be model dot predict. No, it would be model dot, I think it would just be predict, and then be xtest. Actually, what I'll do is I'll do predict later. I'll run this and then I'll go ahead and do predict and all the rest. So now we'll go ahead and score it, and we'll see what logistic regression gives us, unless we get an error. Test. Okay, so that was an okay amount. Let's get rid of this. No, let's leave that. Pipeline. Now we have our categories, average, column, so that if there's an error, we'll likely need to flip these, but I'm not sure. And then this also might be screwed up. But let's go ahead and see what happens. So if we run it, we get an error. All estimators should implement fit and transform, or drop and pass through. So then let's go ahead and flip these then. So I was afraid of that. So if we were to flip this, what would happen is we would have our transform and then our column. So then we'd have our transform and column, and let's see if we screw up anything else. So no, so that's what it was then. So in essence, when we work with the column transform, we would want to make sure that transform is first, and then the column itself. Okay, not bad. And then that was a score of 65, but we don't really care for the score right now. It's mostly about memorizing kind of this, at least being able to recall it without needing to look for help and or referencing my flashcards. So yeah, not bad. Okay, now let's go ahead and move on to the prediction. So model.pred, is that it? Or is it predict? So it would be xtest, and let's go ahead and save it to ypred equals that, and let's go ahead and do ypred proba, because this is a classification problem, we can do it. Ypred proba equals model.predict proba, and then that would also be xtest. And now if we were going to go ahead and do a confusion matrix, what would it be? So what would be confusion matrix? Confusion matrix would be blank. So we need y true, which is y test, and then ypred. Perfect. Labels, do we need anything else? Probably not. But what we could do is we could probably even turn that into like a heat map. So let's do this. Let's go ahead and do conf matrix. We'll go ahead and equal that. And then let's go ahead and do Seaborn. So what would we need? I'm trying to recall how to create a heat map. sns.heatmap would be conf matrix. And then from there, what would we need? I believe the CMap we will need. What would we want that to be? Let's do yellow, green, blue, maybe? Is that how you spell it? If not, like, if there's an error for like the coloring, it's pretty cool to give you like selections to choose from. So we'll want to do FMT, which is equal to I think .2f. And then from there, what else? Let's go ahead and do I'm not sure I need anything else, honestly. So we have the data, the vim, the vimx, the center robust, annote. Annote will be true. I think, right? Data, vim, data, cmap, robust, and then where's annote? Annote is a bool, it's full, false or true, and then perfect. And let's go ahead and see if this does what we want it to do. I guess not. So we forgot to make that equals. So ypred equals that. Okay, so I see what we're doing here. So in essence, what's happening then is, so for every 0 that there is, our model is predicting that 98 of those are in fact like 0, like meaning a what was it? It goes false positive, true positive, false negative, false positive, something like that. But in essence, it's kind of simple to read. So the higher the number is for 0 and 0, the better accuracy at predicting your model is. And likewise, the higher this value is, the better it is at predicting if something is true or not. And it looks like our data is not as good at predicting who did not survive, but it's not very good at predicting who did survive. So yeah. So that's something to kind of consider. So that would be the confusion matrix. And that was really kind of what will lead us into like our evaluating the remainder of the model. So evaluate the scores. Sure. So confusion matrix, and then what else do we need? So we need accuracy and all the rest. So let's go ahead and do a classification report. So how would we do that? And I believe it would be y true and y pred. Yep. So y test, y pred. And then we could also do, even though the classification report will pretty much give us all of the remaining stuff, let's just type it out the rest and just kind of see what the results will be. So accuracy score will go ahead and be y test, y pred. And likewise, I believe precision, nope. Precision will go ahead and be, what would it be? Actually, I believe it would be precision score. Will be again y true and y pred. And then we also have F1 score, and that'll be y true, y pred, right? And then from there, we also have accuracy, precision, F1, and then recall. Even though they'll also pop up in the classification report. Okay. So let's go ahead and see one more time. Yeah, so how can I make that look better though? Because it doesn't look very good right now. I'll just leave it alone. So we have our precision, our recall, the F1 score right here, and that'll kind of give us like what we need for those. And let's actually wrap these in just print statements, right? So let's go ahead and just do print, and let's copy this so it's faster. And then one more time, well, 2 more times. And then this one, I probably, no, I didn't need to do it. Yeah, so this will be the accuracy, and then we'll just make this somewhat look like readable. And this one will be precision, F1, and then the recall. Perfect. And that'll give us like kind of the score for like all these and whatever else. So it's not very good at recalling. The F1's meh, and then precision is okay. And then what else do we need? So we need also cross-val score, but let's wait to do that. No, it would be cross-val. It would be ROC curve, that's what I'm thinking of. So ROC, now that will have a what? I guess a false positive rate, true positive rate, and thresholds. I do remember thresholds. And then somehow that'll equal our ROC curve, or is that AOC? I think it's ROC AOC curve score, but I'm not positive. So what would it be? So it'd be Y test, Y pred. I think that it actually would be the score itself, not, not AUC. So let's go ahead and check out this one more time. ROC curve. So that's still Y true, and then it's Y score though. Now what would be a Y score? Y target scores can either be probability estimates, so that would be then our Y proba. So it'd be Y true, and then Y proba, because it's the probability. Now I read that really quickly, and I'm probably going to be wrong, but we'll see what happens. A bad input shape. Oof. I think I'm actually going to go ahead and just kind of look up this one, mostly because I'm not as comfortable with the RC curve AUC. So how would we view this? And then what we'll do is copy, paste. So would have false positive, true positive thresholds. And then the matrix, so it'd be the Y, the scores. Now what would the scores be though? Can we see it? Can I see it from here? So what would the score be though? You don't set a threshold yourself, that's fine. It would be overkill to explain again here and the rationale. Just go and read more documents. I could totally spend time reading this, but I just don't want to. I just want a simple one-liner. So the true positive, true negative, that's fine. The ROC AOC curve. So right, positive, positive, negative, negative. That reminds us of our of our confusion matrix, which he's describing right here. What else? I really don't want to spend time looking through this, but so what would the score be though for it? So since we're already on Google Colab, let's go ahead and just see like what score would be on here, and then I'll just kind of move on. So it's the target scores. So it can either be oh it can either be, I thought neither. Can either be probability estimates of the positive class, confidence values, a decision function. So I'm going to go ahead and review the ROC and AUC curves and maybe create some more flashcards with those. But for now, let's go ahead and just see like if we've missed anything. We've gone over accuracy, F1, recall. The only other thing would be not cross-val, but I always mix up cross-val score. Oh yeah, cross-val score. I always mix up cross-val score with CV equal to 5 from randomized search CV. So let's view the cross-val score. And how do we do that? So we'd have our estimator, which would be random forest. We have our X and our Y established. Although I could see there being some potential mismatch right here, because we technically in the pipeline we fixed X and Y, we didn't do it outside of the pipeline. But we would be able to use cross-val to evaluate our scores across the different data sets. So let's do, what can we do? Can we do pipeline? Can you use like cross-val with a pipeline? You probably could, but that'll be something I'll need to search like later. So let's just do X and Y. X will equal to X, and then Y will equal to Y. And then from there, what do we want? We could do CV equal to 5. And then let's do, how about verbose? Right? Verbose equal to 2. And then fit parameters, nope. And let's just run it. So I did get the error because it wasn't converted. So what we could do, can I actually go back and use, what would I use? So this is in the pipeline. I'm assuming we could still connect the pipeline to our cross-val score. But I'm not confident in how I'd be able to do that. So what would I do? I know I would want to create a dictionary. I know we would have to work with like the different processing steps. So what we would do is like we would call preprocessing. Preprocess would go ahead and equal, I think, cross-val or something like that. I just don't remember how to do it as like a dictionary. I do know that you can adjust the hyperparameters as part of your pipeline, and likewise you could do it for cross-val, or at least that's what I'm assuming, but I don't fully remember how to do that. So just to save time and to finish like working on this, what I'm going to go ahead and do is let's go ahead and do, let's see what our copy is. So dot sum, so we still have our old data, and then let's also see like what the data type is. And as long as they're all numeric, we should be good. So sex is not. I thought I saved it though. I thought get dummies would go ahead and save that for us, but I guess not. So let's go ahead and just rerun it. And then from there we could just call like the head. So df copy that head. Maybe not. That's right, because it's already been done, so we wouldn't be able to do it again. So yeah, so that would actually make a lot of sense then. Yeah, so what I'll do is I'll just close this out, so that way if the data is rerun again, then you can go ahead and see it. But let's go ahead and rerun it down here. Now we'd see that we have more values, but they're also numeric. So from there, let's go ahead and do the cross-val score with this data set. So what would X be? So X will go ahead and equal dataframe.copy. Let's actually drop one of them. So let's go ahead and do dataframe copy.drop. We'll do, I think there's 2 survived. So we have 1 survived, and then where would the other survived be? So it'd be P survived. So let's drop this one, since that's what we would like. Survived. Access equal 1, and then in place equal true. And then from there, what we could do is we could do dataframe copy. And then what else? So if we're going to drop that, let's go ahead and create our X and Y. So X will be dataframe copy.drop, and then that'll be survived as well. And then access equal 1, and then that'll be that. And then Y will equal dataframe copy.survived. And then from there, we could go ahead and create our cross-val score, which I pretty much saved. So it would be cross-val score. We'll do random forest classifier. X is X, Y is Y, CV5, and that should be good to go. No, and it did not. Did it? Did it? Did it not? Porque no. So, cannot convert a string to a float. C401. What would it be though? Did we really have all? Oh, we did. No. Okay, we need to finish dropping more columns then. What we can do is let's drop all of these as well. And what we'll do is that, and then what else do we have? We'd have our ticket, and then hopefully that's it. So object, we have a float, int, this object, ticket, is already being dropped. Oh, is that the only one? No, then we have p drop. So let's try it one more time. It'll probably be an error again. Yeah. So couldn't find or survived, and then ticket are not found in it. So let's go ahead and rerun it again. Shoot. What we could do is we could always just go ahead and rerun them all. Oh, but I hope I don't have to log in again. So that's fine. And then boom, 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 boom. And then boom, 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 boom. Good. Looking better. And from there, we drop p survived, p ticket, and then ticket. So if we have our ticket, just checking one more time, and then we have our p ticket. And then hopefully that will, actually let's go ahead and just save this as our data frame. So we'll save it twice. And then we'll do data frame rerun, and then we'll do data frame rerun. So then we don't have to really worry about that again, or like bringing back up our data frame copy. No, so the p ticket's still not found. We have our copy though. That's so odd. So why did it populate then? So if we look at it, yeah, I guess the D types one more time. So we have the object for a ticket, which would be right here. And then we have p ticket, which is so odd because it still exists there. That's the data frame copy, and again data frame copy. So why would this not load? Oh, wow. For those that know SQL, what we need is we need a little percentage sign right there. Oh boy. Hopefully it works. Yay, it works. Perfect. And then we see that random forest works a lot better on the data set. Although we have a complete mess of data right here, it still works. So that's good. And then what else did we miss? So I've worked with quite a bit. We've gone through what says probably is 50 lines of code since I reran it again. What do we need? So we've done accuracy, recall, precision, F1 classification, confusion, this, meh, and then the only other thing would be randomized search CV as well as grid search CV and tuning the hyperparameter then. So we've done this. I could do these, but I don't really want to. Actually, no, I could probably call k-nearest neighbors for it. So let's go ahead and do k-nearest neighbors, and then let's do grid search CV. So we'll do we'll do RS for randomized search, and then we'll do KNN will be randomized search CV. Nope. Randomized dang it, random I search CV, and then from there we'll do the estimator, and the estimator will be k nearest neighbors. Oh no, and then we need to do the parameters. I was so happy, I was almost done. This has been like an hour and a half. Okay, let's just see what the parameters are because I really don't know what they would be. Dot get params. Do I need this or not? I guess so. Maybe. I guess not. Yes? No? And another error. One more time. Okay. What am I doing? So do we need the parameters of that? But then, why would we have this? Dot get params. So it's missing one requirement, and the required position is self. So what is self? So it returns the parameters mapped by this. So do we need both? I don't know, that just seems weird. But we kind of know it, and what we're gonna do is we'll go ahead and create a dictionary. Oh no, but I don't know any of these. So shoot. Okay, what I'm gonna do then is we'll do KNN params, and then we'll just create like a random dictionary of just random stuff. Let's just copy all of this, and let's leave it here, and let's just say, let's go ahead and look up like what the best parameters might be. Oh boy. So KNN, K nearest neighbors, how do you spell it? No. K neighbors classifier. Oh, I guess I am doing K. Oh well, I'll leave it alone. I'm not going to question what I've typed out. K neighbors classifier parameters. SimpleImputer learn, and let's go ahead and copy this, and let's view what the better parameters might be. So what would, so something like this, like that's kind of what I was aiming for. So neighbors, we have neighbors 5, but where was auto? I read auto somewhere. Okay, so it looks like it could be these. We're just gonna copy and paste them, and then let's go ahead and see like what the output would be. Aw, lame. So now I gotta, we gotta turn them into strings. Wow. And then we'll do one more. And then we'll do one more. And what would the other stuff be? So we have algorithm. The leaf size is an int. So let's go ahead and just make up some ints. We'll do 30, 60, 90. And then what would the metrics be? And the metrics are a string. I'm not going to mess with that because I'm not really sure what I'm reading. And then what else we have? The metric parameters, they're dictionary, so I'm not going to mess with that either. And actually, let's check out the weights. So I'm curious about the weights because they are correlated, or they're related to what's it called? To TensorFlow. And when you create like a neural network, so weight function, possible values, uniform, distance. Okay, so or callable. Interesting. So let's go ahead and do distance. And I'm just going to get rid of these since I don't want to worry too much about them. So we have this distance. Stupid. And then what else? We would have distance and one more. I think it was like uniform, but I'm not sure if that's the default. Nope, it would be uniform, and then we have a callable. So user-defined function. That's interesting. Which accepts an array of distances. What's a distance? And returns an array of the same shape containing the weight. Okay, so not too bad. Now let's go ahead and run this. So create the param for randomized search CV and grid search CV. And let's go ahead and add that there. And then what else do we have? So we have n iter 10. Actually, I need to do, let's go ahead and just do, like, to kind of keep this uniform, param, I don't know what it was called, so it's b param distributions, right? And then the other one would be estimator. Estimator equals that. Params will equal that. Let's do, what else do we want to do? We could do scoring the jobs, the refit CV equal to none, verbose 0, and then you could random state it. I didn't know that. It's cool. So random state is the same as numpy.random.c. So now that we've kind of got everything set up for randomized search CV, we have our estimator, our param distributor. What else do we need? Verbose. Let's go ahead and do CV again. Let's do CV equal to, like, how about 10? And then n iter will go ahead and be 20. So that's either going to be 200. That actually might be too many. 200 or 100. Yeah, no, that'll be 200 iterations of CV equal to 10. So let's actually make that, let's just leave it as 5, and we'll just change the iter as 20. And then do we need anything else? Maybe verbose. Verbose equal to true. I still don't know what verbose means. And what else? I don't know. Let's just run it. Let's see what the results are. NKNC. And let's change that to K neighbors classifier. Oh no, I forgot. Forgot to run it. Run it. Run it. Did I screw it up? Nope. So we have the K neighbors classifier, estimator param, boom, CV5, verbose, true. Let's do verbose too. Still the same thing. What are we doing? I feel like I'm screwing up. Why? Why am I screwing up? Why is this not working? So we're calling it, we're saving it. We saved it to a variable. We have randomized search CV. What am I forgetting? We have our weights, we have the parameters, uniform, weights, distance, uniform, so on and so forth. We have it called, but it won't run for K. Why not run? Param is equal to here, the leaf, the weights, CV equal to 5, the algorithm, the leaf itself, metrics, and all that. Oh. Whoops. Okay. No, I don't need that though, do I? Okay, interesting. So that would make sense then. Okay, so then this is a learning moment for me. So when we have the data, we split it for a cross-val score. We can use our x and our y. Cross-val score can be done here. When we adjust the hyperparameters with randomized search CV, I'm not going to do grid search, by the way. We need our x test and our x train and so on. So is that why we have random state here? Yep. Okay. So then for fun, let's go ahead and split the data again into train and test. And then we should be done. So x train, y train, what are we doing? Y train, y test. Did I do that right? Y test equals train test split x, y test size will equal 0.2. And then from here we could do random state, or not. We could do random state here, or we could do it right here in our randomized search CV. So if we did that, what would we have? So random state will go ahead and equal 42, which will be the same pretty much as random numpy.random.seed. And from here, we'd have x. Would it be test? Yeah, it would be test. Test and test. Boom, boom. No. No. Why am I failing? Object is not callable, right? But we called this. So what would that's 12. The error is right here. Random search, K and C. Now we have the estimators, the parameters, CV5, but the randomized search CV is not callable. So then, do I not need it? I'm confused and I'm failing miserably. So let's go ahead and see. Let's save it. And let's go ahead and see. Okay, let's save it again. Command C. And then from there, let's go ahead and see like an example of it. Mask, you have the params and all that good stuff. We have CLF, we have our data and our targets. So this would be the X, this would be the Y. So is it just X and Y then? I feel like it should be. Let's go ahead and try one more time. Right? Nope, I'm failing. All right, let's go ahead and read it. So we have CLF, and then we have the information. So the logistic is the logistic regression, and you have your hyperparameters. From here, we have a different distribution, which will be the uniform, which would be penalty. So this one, in essence, yeah, so it's a dictionary. And then it should be a dictionary for both the location and then the scale. C, and then the penalty would be L1 or L2 or L1. And then if we did that, CLF.fit, oh, come on. I didn't do it. Oh, good job. Okay, so let's go ahead and fit it. Let's do X test, or like, let's see what the. Actually, no, I wouldn't need X test or X train because we do have CV equal to 5. Wow, epic, just epic in all the senses of the world. I'm being weird right now. I'm sorry. So then we just do dot best params, right? And then dot best params underscore. What would that be? Oh yeah, it's gotta go through it a couple times. Dope. So this is the best parameters. And what would the score be? rscanc.score. And then we have our x and our y again, I guess, since we don't really need to worry about it. Right? Do we need that score? What would it be though? Run it, see what happens. 1. Okay, so that's wrong. And then if we were going to go ahead and see our parameter, or like, I guess that would be it then. So that would just give us like our best parameters for it, right? They give us the best parameters. We'd be fitting right here, and And how would we view the score? Score anywhere? Scores everywhere. Grid search CV and then randomized search CV. Let's go to the bottom. Let's see what the results are. So here fit, we have our params, and then we have dot best score. So that I did not know. So then that would be our best parameters. Let's actually do this on a separate line. So then we have dot parameters and then the score itself. And then it would be rs and the KNC and then dot best score. So our best score would be a 67. I actually want to see the best parameters though. And then let's just do print for both. Okay. And then print. Okay, so that would give us our best parameters and then likewise the score itself. Alright, so that was a lot. Definitely some learning moments, especially with ColumnTransform, get dummies, joining the data, which I didn't actually go back to merge, so maybe I'll do that next time. And then with regards to this as well, using the cross-val score and the randomized search CV. Now grid search CV would be in essence the same thing, you'd just be training on everything against everything. So then you would just need CV equal to 5, and then from there, yeah, so I guess for myself, the best thing that I can do moving forward, ColumnTransform, cross-val score, randomized search score, and then what would the other thing be? There's one more I'm blanking, and that would be ROC, AUC score as well. So for the most part, not bad. I'll go ahead and end this video here. If any of you guys would like, please feel free to book a Snugg session with me in the link below. I'd be happy to go over any SQL or any of this, honestly. Like, I feel quite confident with this, and I'd be able to help out at least maybe a newer individual, especially with the pipeline or just whatever else. So yeah, so I'll go ahead and end this video here. Feel free to click on any of the links below, and I'll go ahead and see you guys in the next one. Thanks.